And please remember that you have to understand on how to write the equations of voltage V for each closed loop. You already learned about the difference in between the nodes and the loops. The nodes is for the nodal and loop is for the mesh. And you have to remember this. So here is the resistor. Okay, in order to understand the mesh, you have to find the voltage for one loops, around the one's loop. For example, if you have a circuit that look like this one, in mesh, you have to do the KVL. So this is only one loop. So this is the loops. Okay, so I mark with the I1 here, and then this is the voltage source, and then I choose 2 ohm and 5 ohm for the resistor. So actually, if the circuit consists of one loop, actually you can use the KVL methods. The mesh is applied when the circuit is more complicated. For example, it consists of more than 2 loop, 3, 4 loop. If 2 loop, it should be loop like this one. If 3 loop, maybe it can look like these kinds of circuit. So you have to do the looping for each loop, and maybe the circuit will become like this one, which is it will become complicated circuit. So for the mesh, you are applying a KVL into the equations of mesh. For example, for the circuit, we can write that KVL at loop 1 is equal to minus 10 plus with the VR1, which is, if you take a look, that the current is entering your R1, and then it polarity should be look like this one, and of course it will become the positive. So what is I? So I1 times with the R1, this is a Ohm's law, plus with the V at R2, I2 times with R2, then equal to 0. And then from here, you can find the currents. I1 is the I that you have to find. So R1 plus R2 equal to 10. I1 is equal to 10 over R1 plus R2, which is 2 plus 5. So 10 over 7. So you can calculate by using the calculator. So this is a general step for using the mesh analysis. So take a look at this step. For the first step, you have to assign loop for each meshes in clockwise. So I give some example. What is the meanings of this step? This is a simple circuit. So it consists of 2 loop. So first there is a assign loop for each meshes in clockwise. So this is loop. This is the meanings of the first step. And then we mark with the I1 and I2. For the step number 2, decides the numbers of equation. The circuit only consists of R and dependent source. For numbers of loops is equal to numbers of KVL. So, if we reference to this circuit, it means that it consists of two loops. Two loops. So, numbers of KVL is 2 KVL. So, if the current source exists at the outer branch, so no need to do the KVL since the mesh current is already given. The objective for the mesh is you want to find the looping current. Yeah. So for this things, the meanings of these things is if you have a circuit that look like this one, see, I choose 10 ohm and 2 ohm here, and then I select 1 m. So the meanings of this statement is no needs to do the KVL equation for the second loop. So this is the first loop, and then this is the second loop. So no need to do the I2 because the I2 is already given by the circuit. So you can see that here is I2. So the flow is same as the current source as stated in the circuit. So it means that the I2 is equal to 1 M. So you already know the values of I2. This is the meaning that no need to do the KVL for that loop. But then, for the first loop, then you have to do the KVL in order to find the I1. Okay, I referring to the first figure, so this one will be the second figure. So for the step 3, apply KVL for each mesh in the circuit. So the main loop voltage drops added, and the voltage at the adjacent loop is subtracts. I will explain about this one later in the next slide, and after you done all the equations for each loop, then calculates the mesh current using Cramer's equations and the calculator. So here is the explanations for finding the voltage for each of element. Please remember that you have to find the voltage because the mesh is much related to the KVL. So KVL is a summation of voltage in the closed loop. We assume that the current entering the resistor, the polarity setting is always positive. As I mentioned previously, when the current is enter your resistor, we assume that the polarity is positive. Yeah, this is only assumptions. Okay, and then you can know the polarity after you solve all the equation. Automatically, you are able to find the real polarity for that resistor. So for example, if you have these kinds of circuit, so this is the circuit that consists of 20 ohm resistor. If you are doing a KVL equation at the first loop here, this is the first loop, and then this is a second loop. So from this circuit, it shows that you have to do the KVL at the first circuit and the second circuit. As for the first circuits, you are considering that the resistor is sharing in between the loops 1 and the loop 2. Okay? So in order to find the voltage for the 20 ohm resistor, if you are doing the KVL for the first loop, the voltage for the 20 ohm is, you can see that the current is flowing, look like this one. So for the red color, it will become the positive, and then the equation will be plus 20 times with I1. Because of this is the first loop, which is the loop is owned by the I1. So 20 times I1 is Ohm's law, which is V equal to IR. So the owner of the first circuit is I1, and then the resistor is 20. At the same time, you have to consider the I2, which is in a opposite direction. So in order to find the V at 20 ohm, you have to consider the adjacent loop, which is, it will be subtracts. Okay? It is because in this branch, the I that is flowing through the 20 ohm will be I1 and I2. Because of the dominance of the first circuit, you have to consider that the dominance of the first loop is I1 minus I2. So actually, by using the Ohm's law, V for the 20 ohm, considering the dominance of the first circuit, which is I1, is I1 minus I2 times with the R. And then if the I2 is dominant, which is you have to find the KVL for the second loop, which is the I2, the Ohm's law will be V equal to I times R. Dominance is I2. So I2 will subtract the I1 and times with the R. And then, so this equation will becomes like this one.